All right, guys, so we are getting very close to being done with all of our content here, but we've got to get through exponents. So I appreciate those of you that are doing everything that you need to be doing here. Today's notes are only 3 questions. So if you watch this completely, we should be in and out, and then you should be able to do your skill check pretty easily. So first thing that we do here is when we look at this first question, we want to start thinking about whether or not it has to be rewritten before we even start. So when we think about whether or not things have to be rewritten, there's a couple things we need to look for. So we start by looking to see whether or not we have any negatives. Well, here we don't have any negatives, so we're good to go there. And then the other thing we want to do is we want to address anything where you think that there's no exponent because there actually is one and it's very important. This 8 here is actually 8 to the power of 1. So now when I don't have any negatives and there's no parentheses anywhere in the numerator or the denominator, I can start by just multiplying my like bases. So I'm going to start with my base of 8 here, and I'm going to simplify along the numerator first. So when I multiply my like bases, my base stays the same, so it's still 8, and then I do 8 to the ninth times 8 to the third, and what that means is I add my exponents. So this is 8 to the power of 12. Well, then I go ahead and I address my threes here. So with my threes, I have 3 squared multiplied by 3 to the power of 4. So right there, I'm still going to have a base of 3, but 2 plus 4 is going to give me 3 to the power of 6. I'm going to continue with my threes here in the denominator. So that's going to be 3 to the power of 3 multiplied by 3 to the power of 5. Well, that's going to give me a base 3 to the power of 3 plus 5, so 3 to the power of 8. Well, now I'm going to address my 8 here, so that's going to give me 8 to the first multiplied by 8 to the fourth. So that's going to be 8 to the power of, and this is where that 1 is so important because if you don't have that, you might put 8 to the power of 4 when this is actually 8 to the power of 5. So now we're getting very close to being finished here, but we can only have one of each base in a final answer. So I have an 8 in the numerator and the denominator, that's no good. So I need to only have one 8. So I need to think about where it goes in the final answer. Well, in the numerator, I have 8 to the power of 12, and in the denominator, I have 8 to the power of 5. 12 is bigger, so my 8 lives here in the numerator, and that is 8 to the power of, well, 12 is how much bigger than 5? That's 12 minus 5, so that's 8 to the power of 7. Well, now I go to address my denominator, and I have 3 to the 6th and 3 to the 8th. Well, the 3 is, the power is bigger in the denominator, so the 3 is going to stay in the denominator there. And that becomes 3 to the power of, well, 8 is how much bigger than 6? That's 8 minus 6, so that's 3 to the power of 2. And that right there is your final answer. However, there's one other way you might see this as the final answer, and it's only because we know what 3 squared is. Now, 8 to the 7th power, we'd never solve that out. That would be ridiculous here. But 8, this could also be 8 to the power of 7 over the value of 3 squared, which is actually 9. So either one of those would be correct. You'd never see both on a multiple choice test because they're both correct, so don't stress about that. But that right there is the final answer. Remember, you could have both terms in the numerator, you both could have both terms in the denominator, or you could have one of each. It depends on where the powers are bigger as you're simplifying. All right, so the second question is very, very similar. There's just one thing we have to do before. So the first thing I'm going to do is when I look at this, I notice all of a sudden I have a lot of negatives. Here I see a 5. I'm going to address this immediately. I'm going to make this 5 to the power of 1. Well, now when I start to look at this problem, I recognize that all of these negatives mean that this problem will be more simple if I start by rewriting the problem. So what I'm going to do here is I'm just going to state that that is equal to the same problem but without any negatives. So to do that, I just rewrite it and the positives stay where they are and the negatives flip. So 4 to the third is already in the numerator and it's already positive, so it stays in the numerator. 5 to the negative 8th is in the numerator, but it needs to become positive, so I bring it to the denominator and make it 5 to the positive 8th. Here I have 4 to the negative second in the numerator. To make it positive, I bring it to the denominator and make it 4 to the positive second. Finally, here I have 5 to the first, so I leave it there, and I make it 5 to the first. In the denominator here, I have 5 to the negative third. I'm going to flip it and make it 5 to the positive third. I have 4 to the third here, already positive, so it stays where it is. I have 4 to the negative sixth. I need to make that positive, so I bring it up to the numerator and make it 4 to the positive sixth. And then 5 to the fifth is already positive, so it stays where it is. At this point, this question is now exactly like the one above it. I don't have any parentheses, so there's nothing weird I need to do with simplifying. So I just combine my like bases. So 4 to the third multiplied by 4 to the sixth. Well, that's going to be 4 to the power of 3 plus 6, so that's going to be 4 to the power of 9. Well, now I'm going to address my 5s here, so that's going to be 5 to the first times 5 to the third, so that's going to be 5 to the power of 1 plus 3, so that's 5 to the power of 4. I'm going to keep going with my 5s in the denominator, so that's 5 to the 8th times 5 to the 5th, so that's 5 to the power of 8 plus 5, so that's going to be 5 to the power of 13. Then when I go back to my 4s here, I'm going to have 4 to the power of, ooh, that wasn't supposed to happen, 4 to the power of 2 plus 3, so 4 to the power of 5. So again, I'm getting pretty close to being solved here. However, I need to make sure that I only have positive exponents. We're good to go there, but I can only have each base appearing one time. So when I go to address my 4s, there are more 4s in the numerator because 9 is bigger than 5, so my 4 stays in the numerator and becomes 4 to the power of 9 minus 5, so 4 to the power of 4. Then my 5 here is bigger in the denominator because 13 is bigger than 4, and 13 minus 4 is 9. So I end up with 4 to the 4th over 5 to the 9th. And that right there would be my final answer because I only have positive exponents and each base only appears once. All right, so this is the last question of the day. So what I recommend you do right now actually is that you write this question down and hit pause. Once you've done that, solve the question out, see what you get. After you have done that, watch the video and see if my work matches your work. So that way you have some practice making sure that you can get this done before you get going. I highly recommend that you rewrite this problem before you start. You should see a lot of negatives here, so that's what you should do. So go ahead and hit pause right now and see what you get, and then hit play when you're done. See what you get, see if your work matches mine. All right, so for those of us, now you're coming back, going to check your work here. We have a situation where we have to start by rewriting. So when I go to rewrite here, I'm going to start by moving all of my negatives, making them positive. 6 to the third is already positive, it stays where it is. 4 to the negative 6 has to switch to become 4 to the positive 6. 4 squared is already positive, stays where it is. 6 to the negative 7th is negative and needs to switch to the denominator and become 6 to the positive 7th. 6 to the negative second is in the numerator, so it needs to become positive. It goes to the denominator and becomes 6 to the positive second. 4 to the negative fifth is already negative. It needs to become positive, so it switches to the numerator and becomes 4 to the positive fifth. 6 squared is already positive. It stays in the denominator where it is. And 6 to the negative 10th needs to move up to the numerator to become positive, 6 to the positive 10th. So now I start by combining like bases here. So when I go to deal with my my 6s, I have 6 to the third combined with 6 to the 10th. The base stays the same, and when I multiply, I add the exponents, so that becomes 6 to the power of 13. So now I go to deal with my 4s here, so that's going to be multiplied by 4 to the power of 5 plus 2, so that would be 4 to the power of 7. So here I've got 4 to the 6th. That's the only 4 thing I have in the denominator, so it's just 4 to the power of 6. So now I go to deal with my sixes here, and that is 6 to the 7 plus 2 is 9 plus 2 is 11. So that would be 6 to the power of 11. So now I go to further simplify here, and my sixes, there are more in the numerator, so that is 6 is going to be here in the numerator. That becomes 6 to the power of 13 minus 11, so that's 6 squared. Then I go to deal with my fours. Well, 7 is bigger than 6, so my 4 is also in the numerator. And 7 minus 6 is 1. So this is actually 6 to the second power times 4. So that's one appropriate answer here. 4 to the first power is just the same thing as 4. But we also could easily figure out what this is because we know that 6 to the second power is 36. So that's really just 36 times 4. And so in a question like this, it is possible that they ask you to keep going. So 36 times 4 there gives us 144. So that is another absolutely correct answer there. But if you got 6 squared times 4 to the first, you're good to go. So be careful in a question like this. So in this one, it wasn't super clear because then I went and I wrote this, but this denominator here was actually 1. So you ended up with 6 squared times 4 to the first over 1. And remember, when that 1's in the denominator, you don't really need it. Since the numerator power was bigger in both of these, there's just a 1 in the denominator. None of the bases are in the denominator, so it's just the same thing as just having the numerator. Now, if both of the bases were in the denominator, remember, this is not what's happening now, but you would need to keep that 1. So if it was something in the denominator, you have to keep the 1 there. You can't just take that value. It's not the same thing. You can only do that when the 1 is in the denominator. So what you're going to do right now is you're going to go over to Canvas real quick, and it'll be labeled Monday in the module, and when you open it up, it'll look like this, and it tells you if you score 2 out of 5 or lower, you're going to have to reset it. You watch this video if you're still listening to me talking, so you are not going to get a 2 out of 5 or lower. Just go step by step, and you will be fine. So thank you for watching. Good luck on your work, and you'll have something else to look at tomorrow. Bye, y'all.